And it's happening. Okay, hello and welcome to the Ethereum Engineering Group meetup. I'm Peter Robinson, and today we've got Dominik who's going to tell us all about Raiden. So Dominik, please introduce yourself.
Hi, I'm Dominik. I'm with the Raiden network team since 2 years and with blockchain since 4 or 5 years professionally. And yeah, I'm happy to be here and to introduce the Raiden network, the mechanics, maybe the reasons why it scales Ethereum, what are the pitfalls, and then we will see which questions you have. Is it more about these, like we can talk about security algorithms of settlement, which would be more formal, or we can talk about how it actually scales compared to how it should scale protocol-wise. So we'll see whatever interests you, and then we can talk about that. Okay, let me show the slides. Oh yeah, I can share the screen. So you see the screen, right?
Yes.
Yes.
Perfect. Okay. So yeah, like as I said, I'm a mathematician and philosopher. So I was very interested always in systems, or like blockchain appealed to me as a very interesting system. Not only mathematically, but also from the impact it could have, and philosophically maybe. And my role is I was project manager of the core team basically, and so most of the time I did organizing stuff, writing issues, and but I love to code myself. I would say I'm not very good at it, but I did 200 successful commits to the core software, so I'm getting better. And yeah, what do I want to talk about today? Basically, Raiden as a scaling solution for Ethereum. Raiden is one of the oldest scaling solutions for Ethereum. It's the same, like it's based on the same principle as the Lightning Network in Bitcoin. So a payment channel or state channel tech. And I want to introduce it, like why it is needed and how it works. So let's talk about why crypto might be the best version of money we have. Why isn't it used, or why doesn't it scale? And how Raiden scales crypto, so to speak. And then I'm very interested in what do you think about the network. So yeah, it is kind of interactive, and I don't know who has seen the slides and who has not, but what do you think this is?
Looks like a club card. So given it's Diners Club though, it's probably is it a credit card or something like that?
Yes, exactly. Like it's the first credit card ever introduced by Diners Club in 1950, basically. And I just want to point that out because we are still using that dominantly in the internet to pay stuff. So basically we use a technology that was invented 60, 70 years ago to do electronic payments even today in the internet. And that might not be the best fit because credit cards are based on a system that pulls money. So whoever has the information of here, Samuel, and knows the credit card, who can theoretically pull money from his account. Whereas you can say that in blockchain tech or yeah, how Bitcoin works, how Ethereum works, it's rather to push money. So only I can send money to someone else if I own the private key, and so it's a different system. Some say more suitable for electronic payments, for payments over the internet, where everything you can in theory copy. And but still we pay predominantly with credit card or even PayPal now. And so the question is why why would crypto be a better version of money to be used in the internet or for electronic payments than a credit card? What do you think? Like,
I think it's correct. I think that's a very insightful in-out push-pull. That's very insightful. Yeah, it sounds good. I think the idea of pushing rather than pulling is good.
So I don't understand, why is it pull model, the credit card? Because you swipe the card, or you enter the details of the card. That means you're pushing the amount from your account, isn't it?
Yes, it's but like the example is more when you have the information from the credit card, you can pull or withdraw money from that account. So
Well, if you have a private key of your Ethereum account, one can withdraw amount too.
That's true. That's true. So maybe the example is not, but like you don't show like or an example is that you don't go with your credit card around or with your private key and show it to everyone, and then people withdraw money from it.
Right.
But it's more like you use the card, but all the information necessary is on the card that you publicly show around. And
Exactly.
with crypto,
Yeah,
it should be different. But
the standard argument that we have heard of till now for why crypto is best money is the decentralization argument, right?
mm-hmm.
That you don't
But
have
why
one
is decentralized? Why do you think
well,
decentralization?
you don't have one central bank or something, right? If you have Bitcoin, I mean, the market regulation or the market supply regulation happens in a very decentralized way. There is no one central control of power who can tweak the devaluation or the high valuation of a currency.
Yeah, I think that is a very good point. Yeah, and it is then also cross-border, or there's not one single point of failure, right? With this. Yeah.
Yep.
What else could you think about? Like, or what have you heard about? What convinces you about crypto money in the internet?
I think as a general rule, like if you lived in a hyperinflationary environment, and especially where they lock the banks, I think being able to get your money out of the country, as it were, and or at least get it into a stable currency is really good. So
yeah, definitely. Yeah, to have to be able to exit your own maybe monetary system, and to be more free in your decision. Which any other arguments? Maybe like, and we are on Ethereum, right? So money is not the only thing that interests us in that technology. But yeah, it's I would also say it's actually like convenient to use. Maybe not nowadays, but it should be in the future. So it does not need all the security layers that credit cards or PayPal has to make it secure. Maybe, but I can send one Ether to Sandra, and I am pretty sure when I understand the tech that it will reach Sandra without there's no middleman who can prevent that, basically. But okay, let's assume that crypto is like suitable for electronic payments. So the question is, why is nobody using it, right? And I'm sure like you all have thought about that for quite a long time, and everyone has different thoughts about that. But I want to also collect maybe a few points. Why do you think crypto is not used? Like Ethereum is like there now since 5 years, and at least for payments, Bitcoin and Ethereum is not really used, I would say.
isn't it because of the instability of the currency? So it goes up and down a lot. Volatility.
So like the volatility of the currencies, that is definitely one reason. Yeah. I actually always asked, like we have down in the office a little cafe, and I always ask them, so it would be a huge win if they would accept payments via Raiden at the end. So I regularly ask, so, hey, do you want to accept crypto? And they always say like, this is their main reason. So they want to sell a coffee for euro, right? Or $1. And they don't want to think about what's the price of a Bitcoin or Ether now, and how much would the coffee cost. What else? Are there other reasons?
The processing cost recently has become way too expensive.
Gas costs, yeah, processing costs. Like in this Uniswap boom now, right? So we had gas costs of 300 or 400 gigawatt, which is actually truly crazy. So it costs $2 to send something on the blockchain or so. What else?
General people don't understand it and so don't think to use it for everyday
So
purchase.
it's very hard to understand, yeah, I would say so. Are there any other reasons?
I think there's uncertainty in terms of the processing time, and related to being hard to understand, people are afraid of getting it wrong and losing their money.
Mm-hmm. And it's not even afraid with one F. Yes, and it's not even unlikely, right? So I know some people, they lost their private keys somehow, and then they lost some money. So
I think Anthony's also, he's talking about finality as well, for the uncertainty. I mean, there's two different types of uncertainty. So there's uncertainty due to losing your keys, and there's uncertainty due to finality.
yes.
Yeah. Another one I think I always think of is, have you transferred to the right account number? Because you just get one digit wrong and boom, the money's gone forever.
Yeah, that's also a very good point.
Yeah, I mean, it's funny, in the Enterprise Ethereum Alliance, we're coming up with an ID for cross-blockchain communications, and we're actually putting in 4 bytes of check digits, and they're going to be the truncated hash of the rest of the stuff. But it means that you'll be like a credit card number. So if you get 1 digit wrong in your credit card number, it'll fail. Whereas at the moment with an Ethereum address, you get 1 byte wrong or bit wrong, you know, you're in really big trouble.
The other one that I was just up in 1770 Queensland, which tried to hop on this trend early. And so the vendors supposedly all take Bitcoin and such. Some of them take other currencies. And as far as I can see, nobody uses it. Same thing's true at the Brisbane airport. And the reason for this, really, a lot of it has to do with time. And that goes back to uncertain finality. But just the time it takes to get a transaction through is pesky.
Yep. Like in Bitcoin, it's maybe even 60 minutes, right? So 6 blocks to wait. And
yeah, which is great if you want to replace Western Union. You know, I want to send money home to my parents in another country. That's fine. But if I want to buy a coffee, it's really not the thing.
That's true.
Well, but the other thing as well is that comes back to the uncertain finality. 60-minute people talk about six confirmations, but that's only giving you 1 in a million. So, you know, it depends on how much money you're dealing with. But, you know, if it's a 1 in a million chance that your block will be reorged, or the transaction will be reorged out and then will never go through, I'd want more than 1 in a million. Yeah.
That's also kind of education, maybe. So, yeah, the confirmation blocks. So people need to know how long to wait for which amount, maybe to bear the risk. But I was also here in Berlin. There was a famous bar that accepted Bitcoin, Room 77, one of the first bars in Germany. And I was there and wanted to pay with Bitcoin. And it took so long that we had to drink another beer that was not paid then. And so we had to pay it with beer that you had, or waiting beer. But yeah, I would say that's the main reason, or one of the main reasons. It's just takes too long, and people who would accept it, they do not really know how to deal with that. And yeah, this is exactly like this was known or is known for a very long time, as you all know. And so there are different scaling solutions out there to help with that problem. And one of the oldest scaling solutions, or one of the oldest ideas, are actually state channels or payment channels. And it's a paper from Joseph Poon, published 2015, that lays the basis for Lightning and Raiden, actually. And so, yeah, Raiden aims to solve some of those issues. Basically, I would say scaling Ethereum for the masses was one of the slogans, but what it actually is like for smaller transactions. So when I want to pay my coffee with it, or when I want to have like a paid API, we always imagine Google Maps, for example. I do not pay with data, but I pay maybe 0.0 cent or so for a route request, and there is a Google out there that would give me the route and does not take my data. Such things like you can pay with Raiden, with the scaling solution, and as we will see, you lose a little bit of the security properties, like compared to layer 1 to Ethereum. But for small transactions, it's perfectly suitable because like it's very fast. Like we aim for sub-second payments. It has very low fees. So we aim for $1 or even less. It can even be for free in certain conditions. And the main point about these payment channel networks, as we will see and can discuss in the future, compared to other scaling solutions, Raiden, like in theory, is linear, like scales linearly, which means that the more people you have, the more transactions you can do with the same factor. Because in the network we go for local consensus, so to speak, and again, compared to a normal blockchain where every information must be at every point at some point in time, which then does not scale linearly. Raiden does. We offer or provide more privacy compared to the public ledger on Ethereum. And we try to be as decentralized as possible, but also that comes with a cost. Being decentralized, obviously, is being paid by like not having the performance and so on. So it's kind of a balance, as we will see. But this is the 5th point, and the 6th point is at the moment we go simply for ERC20 tokens. So for that token standard in Ethereum. So these were our goals, or these are our goals, how we want to solve this problem, why crypto is not used for payments. And like a few words about scaling. I think you all know that, but like in this logarithmic scale, you see that Visa like has a TPS of 1,000 or more, and Ethereum maybe 10, and Bitcoin you cannot even see here because it is like 4 or 3. So if crypto should be used for payment, then we need to be like a lot better and have a lot more. Just as a comparison, Ethereum 2.0, they think it will scale Ether with a factor of 1024 at the beginning, because they have 1024 shards as far as I know. So it will be in the league of Visa TPS wise.
I'll have to ask Sandra about that. Who's on the call?
That's what, not on the call. It would be interesting to have insights.
Yeah, she is on the call.
Would you agree to that, Sandra?
Sorry, I wasn't listening then.
No, it's just like what I understood from ETH 2.0 and the proposed transactions per second is that with these 1024 shards that they will have, they will scale Ethereum roughly 1024 times. So we can expect, without another scaling solution for Ethereum 2.0, when we have now 12 transactions, so we will have kind of 12,000 transactions with Ethereum 2.0. per second.
Yeah, I can't remember the exact numbers, but I know that they're substantially more. And I also know that some of the figures quoted by Visa should be taken with a pinch of salt, but I see that you've got them around 1,000 because they do sometimes mention much higher figures, which are more theoretical than actual.
Yeah, yeah. And I think it's just, I didn't know how technical you at the audience were, so I think you have seen the sheet, but or the numbers, but it's just, yeah, just to get a feeling like how much Ethereum must scale, basically, or what should a scaling solution be capable of to compete with Visa.
I think Raghavendra just put into the chat as well, but I think the design's been changed for Ethereum too. So there's probably going to be 64 shards, but and in fact, I think there may only be a few execution shards, and others might be data availability via roll-up shards. But I think that's a moving target a little bit. But yeah, I think 64 is the initial gambit rather than 1,024 because it was going to be too complicated.
Ah, okay. Then my information was old. But there was a time when they said 2024.
Oh, there was definitely a time. That time has passed.
Ah, okay. Okay.
It may come again.
Maybe it comes again. Yeah. Okay, nice. Yeah, but it will definitely be. Yeah, we can handle much more transactions and. Yeah, but yeah, I'm not an Ethereum 2.0 expert, so but at least what we want to reach with Raiden to be able to compete maybe with Visa or even more have more TPS. This is somehow the goal that we want to reach. That people will use Raiden in the internet for payments. And so obviously, why do blockchains don't scale? I think everyone knows that, but the best point that I always got is that whenever Alice wants to buy a coffee from Bob, basically the whole world needs to know. It's the global consensus at layer 1 that makes a blockchain or like a proof of, that makes it so secure, but also, it comes with a cost on performance. And the simple solution for those payment channel networks basically is they go for local consensus. So local consensus in that sense means only 2 people agree on something and then they submit the information to the blockchain. And I don't know if you have dealt with it already, but I would like you to maybe I need 2 people, an Alice and a Bob, regardless of the gender. But and then we can maybe see how that works. Who would like to be an Alice or an Bob? No one? Okay. That's sad, but
I'm happy to be I'm happy to be an Alice.
Okay, nice. You were David, right?
Sly.
Sly.
Sly. Perfect. Hi, Sly. Okay.
No, Alice,
Sly.
actually. Alice.
Alice. Yeah, true. True.
You don't own a restaurant, do you, Alice?
So, Alice, I have here in the chat, Alice, if you see the chat, I have here a private key for you. It's an actual private key and like a tuple, a private key and a nonce. And I would like you to send this private key or this tuple with an increasing nonce always when you get it. Send it back to Bob, and Bob will take the tuple, increase the nonce, and send it back to you. So basically, you and Bob, which we will find out who this is, like just exchange or ping pong this tuple, private key and nonce amongst each other. And we will see how often you can do that during 13 seconds.
Who's Bob?
Oh, that's a good question. Who wants to be Bob? If
Sure,
not,
I'll
I
be
can
Bob.
be Bob. You
Yeah,
will be Bob?
I'll be Bob.
Perfect,
So-
Peter. Okay.
I don't even know how to send a private message.
I'm assuming it's via chat. Is it via
You
chat?
can do it. Yes, via chat. Okay,
Oh, yeah.
so and it already started. So Alice already sent it to Bob, and
So what am I doing? I'm sending it
to Bob, yeah. And now Bob needs to send it back. So Peter, take the tuple, increase the nonce, and send it back.
All right.
Okay. Do you see the chat, Peter? Yes. Okay. And then, then Alice, you need to send it back again to Peter. So it's a ping pong.
Yeah, we're ping ponging. Didn't you say do it privately?
You do it. Okay, I didn't see it. Okay, perfect. Then the time is over. How often? Like, what's the nonce? Sorry, I didn't see it. Privately is even better.
We got up to 10. We got up to 10.
To 10, perfect. To 10. That's very nice. Obviously, this is not how an Ethereum transaction works, but in theory, like it was one block time, like 13 seconds is the average block time at the moment in Ethereum, they say, and you were able within the time of one block to basically exchange money 10 times, right? So, and this is actually the whole idea, as you all probably know, of being off-chain or being in a layer 2 is to come to an agreement who owns the money off-chain, like via chat or however method, whichever method you want to use, and then at the end you submit it to the blockchain, and the blockchain will settle this information, or it will settle the money. So yeah, and as you've seen, you're 10 times faster than Ethereum, and Raiden actually works exactly like that, but obviously we will not exchange private keys, but do a little more crypto magic that we will look into. But as you see here, what Peter and Sly had actually was, so to speak, a payment
I changed my
channel.
name to Alice, remember?
Sorry, Sly. So Alice and Bob, they had a payment channel, like a very rough version of it. But actually, in their private chat, even they exchanged a message, and let's assume the owner of this message, like the private key in the latest nonce, would be able to claim the money on chain at the end. And this is actually a payment channel. Obviously, in that example, it would not work because everyone with the private key would be able to get the money, but with a little crypto magic, it then is possible, or we claim it is possible. And yeah, this is actually a payment channel. So Alice and Bob would deposit something in a smart contract, like the same type of ERC20 token, and then they can come to an agreement or local consensus. They come to an agreement on how this collateral that they both deposited would be distributed at the end. And then maybe Alice starts with 4 tokens and Bob 2, and then they transact for whatever reason, and then at the end both say, okay, now Alice just owns 1 token and Bob 5. And this is yeah, what a payment channel is about actually. So they basically sign messages. We call it balance proof, and they sign messages and say, so hey, Bob, here now are 2 more tokens, signed Alice. Yeah, and yeah, then they just agree basically on who owns the money. And this is yeah, a pretty simple concept. It is more complicated when we look at the cryptography and security properties, but this is the rough concept. And then with a little crypto magic, the goal is to build a whole network, right? So it would be pretty boring if only Alice and Bob can exchange money and then they go to the blockchain and settle it. But the goal would be that Bob could send money to I call him Hans, and but Bob does not have like a channel with Hans, right? And so Bob uses his channel with Dominik, and Dominik with Ida, and Ida with Hans, such that at the end Hans has more tokens or assigned balance proof of more tokens than at the beginning, and Bob has less, but Dominik's and Ida's balance would stay the same. And that works basically just Bob sends one token to Dominik, and then Dominik has +1, but Dominik then sends one to Ida. So overall netted, Dominik's balance stays the same with Ida, and Hans at the end gets one more. So this is, yeah, basically the very basic idea of a payment channel network. So we chain channels together. And yeah, to make this idea work, there are a lot of problems, security problems, but also performance problems, and like also kind of logical problems, how to find a route, who knows, who has the information about the current state in a channel. But let's see. So how does it work? It works basically like the core concept of these channels, and especially of these like networks. So when you chain channels together, is a so-called hash time lock. A hash time lock, I would define very roughly, is like I owe you, under the condition you can tell me the correct secret, or you can tell me the secret where I have the hash too. Who has already heard about hash time locks? Probably a lot of people here, right? So you're familiar with the concept. Perfect.
Yeah, for sure.
Okay, perfect. Then yeah, the hash time lock is just like it's a conditional payment or a conditional state change. So it gets reverted when it times out, but it gets preceded if there is the correct secret to the hash being sent. And so now let's look again at from the payment, or the payment from Alice to Dominik. It would like with the hash time lock would look like that Alice sends to Bob a locked transfer, which is exactly that hash time lock. So there is an amount there, and there is the hash of the secret, and then Bob sees that, and Bob knows that it goes with the final target to Dominik. Let's assume that he knows the final target, so he proceeds or forwards that hash time lock or a copy of it to Charlie in his own payment channel, and from Charlie to Dominik. And then Dominik basically asks, like in a private channel, Alice, and says, because Dominik and Alice, they know that there must be a payment coming, and when he receives from Charlie the correct hash time lock, he asks Alice directly to secret. So he just has the hash time lock with the secret hash, but doesn't know the secret, and Alice sends the secret directly to Dominik. Actually, it's Dave, but now we go with Dominik, and then he can start to collapse the chain of hash time locks from the end. So now Dominik is in the possession of the secret, and he can tell Charlie, so hey Charlie, look, I have the secret. And then this locked transfer, or this hash time lock, gets unlocked, and he receives the real balance proof. And with that, like this is our version of finality basically in Raiden. Then either you have like an unlock message, or the secret, and then Charlie forwards the secret to Bob, and Bob sends the balance proof to Charlie, and the same with Bob to Alice, and then Alice sends the balance proof to Bob. And this is how a mediated payment works in these payment channels. Are there any questions to that?
So I guess it's fair to say that in sync with item 2 or point 2, that'd be when you're getting your coffee. So the actual goods take transfer. So you say, give me the secret, and then what, you get the secret and then you say, here are the goods, here's the coffee? Or do you ask for the secret and give the coffee?
Yeah, that's like, when would the coffee shop give the coffee? Like legally, we had some lawyers looking into that, and they said what one would be the finality from the legal point of view. From the technical point of view, the transaction is final when you receive the secret. So in the second step, as you said, Dave would request a secret, and when he received the secret and the secret fits to the hash time lock he got from Charlie, then basically it is final, even if he did not unlock the locked transfer. So that would be the final.
But assuming Alice is the person buying the coffee and Dominik is the person selling the coffee, so I do the transfer, which goes through Bob and Charlie to get to Dominik via the lock transfers. And then Dominik says, okay, I can see there's going to be a transfer. And they do the secret request. So as soon as I give the secret, then Dominik can say, hey, I'm not going to give you the coffee after all.
Okay, yeah.
That works with normal money or credit card or whatever. Like some restaurants, you pay first and then they make you the coffee, and some of them you sit down, they make you the coffee, and then when you leave, you pay. So in both cases, the contract has already been agreed, even if you haven't paid the money or paid the money first. So some cafes you pay before, some you pay after. That's not a concern of the protocol, right?
So if you don't get your coffee, even if you have paid, that is a problem. But maybe your question even points to a deeper question. What happens if, for example, Dominik would unlock with Charlie, but then Bob goes offline? And then that would mean the secret never arrives Alice, right? Or the secret never cascades back to Alice, and so she would never unlock, but Dominik already got his unlock bounce proof. And this obviously we have covered. We can look into that protocol wise, how this is being solved. But let's look at the happy case. Are there any questions to the happy case before we go deeper? Basically also here, we just build the chain with hash time locks, and then we exchange the secret from target to source, and then it cascades back.
I don't know if it's relevant here or you're going to talk about it later, but if you're not buying can you mix this with other Ethereum transactions? So if you're not buying a coffee, if you're buying a diamond, then one benefit of an on-chain transaction is that whilst the physical diamond might not be whether you pay before or after you hand over the diamond, you can actually make the exchange of a title to the diamond at the same time as the payment for the diamond. So therefore you can go to the police and say, here's the receipt proof that I have bought, I now own the title of this diamond, but they never gave it to me. Can you combine it with other transactions?
Yes and no. That's a very philosophical answer. It's not that transparent as on the layer 1 blockchain. So if I indeed would buy a diamond, I would not do it with Raiden, I guess, because not every transaction is publicly visible to everyone. But if Alice would buy a diamond from Bob in this example, and Alice would get a signed message from Bob that, hey, I received your hash time lock. Whatever Alice and Bob they exchange, they always sign their message with nonsense. And then I would consider that as a proof, when Alice can prove their payment receipt, that it is indeed signed from Bob. Then
I was thinking more what is it, a 721 token, which is is that unique tokens?
That's what you think. Okay, no.
So you're going to swap a ERC21 for a 721 in one transaction.
Yeah, you cannot do that in Raiden at the moment. There are, in theory, protocol extensions where you can first swap ERC20 to ERC20. and then swap it to whatever you want. But non-fungible tokens cannot be exchanged in payment channels like that. That must always happen in direct channels, or then a state channel, actually like a generalized state channel would be a more suitable solution for that. Because if the token is non-fungible, then obviously Alice cannot send it to Bob and Bob to Charlie and Charlie to Dave, because they must all have the same token and it cannot leave the payment channel. So the Raiden as a concept only works with fungible tokens.
That's fine. That's the
that
question.
Make sense?
Yeah.
Okay. Yeah. Okay. So that's actually the happy case of Raiden, and yeah, maybe not to talk only about code. I wanted to show you how does Raiden look like. At the moment, one second. Our first reference implementation was actually a Python client, which is nice if you want to. We were pretty good at Python, but Python is not the best suitable language maybe for that. And so now we have a TypeScript or JavaScript Raiden client basically that can run in your browser or even on your mobile phone. And I just want to show you a transfer now in that in our newest client. So we have two participants again, Alice and Bob, and they have like it's a girly so TTT token, so to speak. And Alice here, she has two channels, one with a guy that is online but we don't see here, and here this is Bob. You can see it with the blue emoticon, but his address starts with, it's a normal Ethereum address, or ends with FA1B. And let's look if this is indeed Bob. So FA1B, and it has the same icon, so it's safe enough to assume that she has a channel with Bob. And so it's a direct channel. So it is the first example that we've seen from Peter and Shai, or our Alice and Bob. So not the complicated hash time lock thing, but let's see how that works. So I would just say, okay, send a small amount of your test tokens to Bob. And that will be a summary. It's a direct transfer, as they say. So it's not complicated and it is successful. So indeed it was sub-second. And we can see here Bob received some money and now hopefully hands out the coffee. And now we have like a hub running, so a third party here. And let's see how a mediated payment works. But I first have to close the channel here, because it, like Raiden per design, or the client per design, will always take the shortest route, right? And if I have a direct channel and a mediated way, or like a not direct way to my target, then it would always go for the shortest one. We will also shortly talk about that. But now if I want to send money from Alice to Bob again, there is no direct channel anymore. So we need to get the payment mediated over our hub or our third party. And therefore, it is still a direct transfer, and that's stupid with the live demos, right? 1 second. Okay, we have to wait until the channel is closed. That is maybe also interesting to talk about. Like to close a channel and to actually claim the money from the blockchain, we need around 2 hours. And this is artificially set this time because like when one channel participant closes the channel, like it does a on-chain smart contract transaction, and it says like, I want to close my channel with Bob now. And then the settlement algorithm, basically, or the smart contract, kind of waits for the latest state update from the counterparty to have a fair distribution. But obviously, if Bob would never answer, we cannot wait indefinitely. So we have this like 2-hour window where the counterparty can react, and then we settle anyway. And we have other security features that if you are offline or there's congestion, that you get your money out, even if you're not able to publish the latest balance proof. But in this settlement window, it works like that. So let's see if now he knows that the channel is closed. Let's do the direct transfer, 1 second. So they told me never do a live demo, so 1 second. Okay. So okay, now the channel is closed, so now it should work, and it is actually. And then we can do more theory again, because it is mathematically also quite interesting how this how a route can be found. To change my MetaMask. So yeah, I can connect this Raiden dApp, so to speak, with my MetaMask account, and then do these transactions off chain. But I can also do it without MetaMask, so I don't have to sign so much. Okay, so now we enter the address of Bob. Okay. Okay, I don't know. So, okay, we have a bug, but in theory, you would see now a transfer from Alice to Bob over a third intermediary. And I cannot debug right now, but yeah, this is basically, that works since 2 years, actually. I have to look it up why this doesn't work right here. But the interesting part of that is that if you have this payment channel network, then the nodes do not really know what the best path is to the target, right? Because even though in Ethereum, we have in the smart contract a list or register of all the channels, and we know who has a channel with whom in the current implementation, we do not know the current balances in these channels, which means we know that Alice deposited 1 year ago 5 tokens in the channel with Bob, but we do not know who owns the 5 tokens at the moment. So we would not know, can we use that channel to route our payment through? And so, yeah, there are many different concepts how exchange of information in that network could happen, that it is on the one hand privacy preserving, and on the other hand it must be performant, and maybe even like there is even a market that certain nodes can advertise their channels to be used as a mediator to earn fees. So we have basically a layer, our transport layer, or the layer where how the nodes communicate. We use metrics as a system of federated decentralized servers where the nodes can communicate and advertise their channels, but also tell each other what the current status of their channel is if they want. And then the nodes get an internal representation of the graph, or of the network graph, or in the case of the Light client, they can outsource that to another more advanced node to get this internal representation, and then to use a path finding algorithm on top of that internal representation to find a path. And obviously there's also like a timing question, so I can get the information, make my path, but then the network itself could have changed already because there's another payment, right, in parallel. And then there are mechanisms in place that the payment, I don't know, gets refunded. And so you can imagine the complications that are in the detail here. Yeah,
Sorry,
that's
sorry,
actually,
Dominik.
yes.
I didn't really understand why you need to know the balance of each account, because if the same amount is being transferred from A to B, wouldn't that give it sufficient balance to transfer from B to C?
No, because like, let's assume that A sends a token to B, and B sends a token to C, and B wants to send a token to C, right? So when A, like in the channel AB, you need to think about these payment channels as also like lists, and in the channel AB, there might be enough balance such that A can send a token to B, but B cannot use that exact token to forward it to C, because that token is still in the payment channel AB.
It's still encrypted.
Like it is, like that's one of the pitfalls of these payment channel networks. Tokens are bound to channels, like such that we can have the security that B always knows he gets the tokens out that he owns. So we have to make sure that the tokens never leave the channel. So there are some tokens in the channel AB, and there are some tokens, fungible tokens, in the channel BC. And then we can make sure that Alice sends a token to Bob, and Bob sends another token to Charlie, but she cannot, but if she would want to use the same token that she got from Alice, she would need to withdraw that token from the payment channel and deposit it again into another payment channel. Does that kind of make sense? I can show you. Yeah, maybe
I think I understand. Yeah.
Okay. Good. I think. Yeah. Here you can. But okay. Yeah. But so that is one of the pitfalls of a payment channel network. You cannot freely use your capital or the deposit you have, but you always have to. It is basically bound to a payment channel. And yeah, that's also how paths are being found. But maybe it's interesting. Let's see. Oh yeah. Okay. So let's see. So in this case, again, Alice wants to pay to Dave some tokens, and so in a lock transfer, she basically locks 3 tokens, like 5 is the current balance. Now she locks 3 tokens on the way to Bob, and Bob then also needs to lock 3 tokens to Charlie. They also have 5 as an on-chain deposit in their payment channel, so they lock it again. And then Charlie only has 2 on his side of the payment channel, right? As you see here. So at the beginning, they also deposited 5. So Alice thought, she looked at the smart contract and said, okay, that path might be possible. So she's a stupid old node, so she doesn't know the current state, but she knows the smart contract. So there must be a path because Charlie deposited 5 tokens. But in fact, Charlie only has 2 tokens available. So the payment cannot go through because this payment channel has not enough capacity. So Charlie would say, I cannot do it. He would refund the transfer to Bob. Bob would refund the transfer to Alice and say like, well, okay, this way doesn't work. And then, or Bob knows that he has a channel with email, and then they would try another path basically until they reach Dominik at the end. And yeah, you can spend a lot of time into that mathematical or graph theoretical problem. The Lightning guys are very good at this. The Lightning guys at the moment, they have like 14 different pathfinding algorithms in place. They compete with each other. We only have one, but we always look in kind of envy to Lightning because they play around with that. But the main problem is not the efficiency in these algorithms, I would say, but it is what we can see here, and that is also the last slide, that like we have a trilemma in these kind of scaling solutions, and I would even say in all layer 2 solutions, from performance, privacy, and route cost optimization or decentralization. That means the more hops or the more mediators you have in a payment channel network, the more costly it is. So because every mediator gets a small fee, and so you want to have the shortest route or the cheapest route. And but if you want to have a very cheap route or the optimal route for you, then somehow you need to know the current state of the whole network to know that your solution is optimal. But like for the privacy reasons, no one should know the whole state of the whole network all the time, right? So so this is kind of contradicts each other. And if you also want to have a like you don't want to calculate like for years, it's a numerical optimization problem as well. Then the performance dimension also kicks in. So it's a very interesting problem, mathematical wise, I would say, and also like design wise, how to solve that. Yeah, so that is, yeah, like I could talk maybe 2 hours more. I would like to invite you to try it yourself. We have a nice wizard online. It's like it used to be a one-click installer for Girly, but also for mainnet, where you can just try out Raiden on Girly for free, obviously, and on mainnet if you want to use it. You need to have some ether in place, a small amount to open a channel, and then you can try it out. Yeah, and that's actually it. Are there any questions or anything I can?
I have a question actually. How does it interact with the layer 1? Is it a contract on the Ethereum chain?
No. Yes, it interacts like we have like a bundle of 6 or 7 contracts for Raiden at the moment. And like those payment channels, they are, or we have one smart contract per token network. So per ERC20 token we support, for example, DAI at the moment, we support DAI. And then in this Raiden DAI smart contract, or we call it token network contract, and it is basically a register of all the channels that people have. So if Alice has a DAI channel with Bob, it would be in that smart contract. And there, in that smart contract is where the deposit is, or this smart contract is the owner in the DAI token contract of some tokens, especially the tokens from Alice and Bob. And so you need to approve that. And it interacts when Alice wants to deposit or when wants to open a channel with Bob, then you need to write it in that smart contract. If Alice wants to deposit more money into the payment channel, then you need to interact with it. If she wants to withdraw, so get money out, or to close and settle. So at the beginning and the end of the channel life cycle, you interact with the smart contract. And yeah, that's basically it. But we have some more smart contracts for security features, especially this case that Peter talked about. When one person goes offline, we have a so-called secret registry. So another smart contract where you can timestamp that you know a secret at a certain time, a secret for a hash time lock. And with that secret registry, you can prove that you know a certain secret, and then in the settlement period of another smart contract, it looks at the secret registry and then pays you out the correct amount. Yeah, does that answer your question? Or
yeah, so to open a channel you have to deposit, right? And
yes.
It's not like you're depositing once and open like multiple channels. You're depositing each time you're open. Okay,
Yes.
Yeah, that makes sense.
Yes. Yeah. Yeah. Are there any more questions or?
Do you know, well, I suppose it's 2 related things. One is around, obviously it relies on a network and the pathfinding. What about if there's a network split, or when 2, like there might be another person who there is no path to that person? Related to that, is there any analysis around the optimal number of channels to open? Because you obviously don't need a channel for every person you want direct payment for.
No, no, exactly. Yeah. Yeah. So it highly depends on the use case you want to use the Raiden network for. In theory, everyone can have open one channel, and then you can send tokens to everyone in the network. But obviously that's not optimal cost-wise. There are some calculations, but yeah, there's discussion around that. How many channels are optimal, and what are the assumptions to make this calculation. We assume at the moment, but it's very rough, that you need 3 channels, channels to 3 different parties to have good network. But that's I hope that answers somehow the question. But obviously you should never, like the Raiden network is designed that you do not need direct channels to everyone you want to pay for, because that would be like not optimal. Then it's better to do an on-chain transaction. So you should use mediators. And but how many channels you need? We think it's 3, but it's a long discussion. In Lightning, there are actually nodes with more than 1,000 channels, like highly connected nodes that want to earn money with mediation. Does that answer your question, or?
So there are, I might have missed it. There is a fee.
Yes, yes, there is a mediation fee. So every time I am that guy in the middle here, like Bob or Charlie, I actually do work, and there is also a risk involved, and that risk I want to get a fee for. So Alice would pay a small amount to Bob and a small amount to Charlie, such that she can transfer money to Dave. And yeah, in Raiden actually there are 3 fees, so it's a flat fee and then a proportional fee of the transferred amount. But there's also an imbalance fee, which means that somehow we make a path more expensive artificially, that is kind of imbalanced or dried out capital wise, such that to incentivize a path that might be a bit longer, but would balance the network again.
And those fees are all calculated in F, like there's no gas pricing mechanism or anything, they're all just fixed.
Yes, the fees are paid in the token to be transferred. So if you would send 10 dice to another person, then the other person would reach, I don't know, 9.8 die or so, because the person in the middle would get some fees in die. Does that make sense?
Yeah, no, that's fine.
Okay. Are there any more questions, or should we show the last slide and I hand over to Peter?
Yeah, okay. Well, thank you for a fantastic talk. Oh, can you hear me?
Yes.
Brilliant, yeah. So thank you for doing a fantastic talk. That was really informative. I'm actually driving right at this instant, so can't actually see the slide. So it's going to be, we're going to see if I can remember what the forthcoming talks are. So the talk in just actually next week isn't a talk at all. We're going to try something different. So a lot of people have said that they're looking for work, and I've had other people who've come to me saying, do I know any good blockchain engineers or smart contract developers? And so we're going to essentially run an online job fair. And so what we're going to do is every 10 minutes, across about an hour, we're going to use the breakout room feature to put about 5 or 6 people into a breakout room. So say if 30 people come along, then chances are you'll get around to meeting everyone across that 1 hour period. And so the hope is that we'll connect some people who are looking for work with some people who are looking for people to fill roles. And yeah, it'll be a fabulous outcome if some people get a job out of it. And then in 2 weeks' time, we've got Alexei, who's going to talk about TurboGeth and what that new Ethereum client can do. And then in 4 weeks' time, we've got Konstantin coming along to talk about Scale, which is another layer 2 solution. And then on the 9th of December, so it's either going to be David Highland Wood and myself, or maybe it'll be some people from the Protocol Labs group, are going to talk about Filecoin. And so that'll be really cool. And then we're going to have a break over Christmas, New Year, and then we're going to have Piper come along and talk about stateless Ethereum and Ethereum 1.x. So there's a massive program, and yeah, I hope you can all come along to the talks. Yeah, so it should be good. Yeah. So anyway, look, thank you again. Oh, sorry.
Thank you very much, Dominik. Fantastic talk.
Thank you,
My
Dominic.
pleasure. Thanks.
Great.
Thanks, Dominik. Thanks, everyone.
Yeah. Thank you. It was awesome. And have a great rest of your day.
Thank you very much. Have a nice day.
I got to
Bye.
change my name, but Peter didn't change his. So I was disappointed.
That's true. That's true. Feedback taken. Thanks.
Okay.
Bye. Have a nice day.
Bye.
Ciao.
Everyone.
Bye.
Bye.
Thank you.